improper rotation. Okay, improper rotation is actually a combination of two symmetry operations. One is a rotation followed by reflection. But here there is something you have to be very careful about. Rotation is through a particular axis, and reflection is the reflection plane is perpendicular to the rotation axis. So you can see this molecule here. This is methane, carbon with 4 hydrogen atoms, CH4. We have just tilted it a little, and this is the axis. You can see this axis passing through the center of carbon. We have two hydrogens on the plane, and this hydrogen is facing towards us. The other hydrogen is away from us, or it's behind the screen, and this is above the screen or above the plane. Okay, and now we are rotating this molecule through 90 degree. We are rotating this molecule through 90 degree in the clockwise direction. So these two hydrogens are now on the plane, and when we rotate it through 90 degree in the clockwise direction, this hydrogen will be facing us. This hydrogen will be going behind. That is, it will go behind the plane, and we have this hydrogen which will come to the left hand side, and the one behind, it will come to the right hand side. You can see here the one which was away from us, or which was behind the screen, has come to the right hand side, which the hydrogen which was facing us has come to the left hand side. The hydrogen on the right hand side, the hydrogen on the plane on the right hand side will come towards us. It will be pointing towards us, and the hydrogen on the left hand side has gone behind the screen. It has gone back. Okay, so here we have this is the line of symmetry, or the rotation axis. This mentioned as the rotation axis, but has it produced a similar appearance? You can see here it's entirely different from what we have seen in the first orientation. Okay, so here we haven't got an orientation which is similar to the first one. Okay, here comes the next part. The first is rotation, and now we have a plane, that is the reflection plane, which is perpendicular to the axis. This is the axis. Here this is the axis, and what will be perpendicular at 90 degree. So the plane will be passing through carbon, and it will be perpendicular to this first axis. So here is the plane. Here is the plane perpendicular to the rotation axis, and again we are reflecting through this plane. We have the carbon here. The half of the carbon which is down, it will reflect to the upper side, and the one on the upper side, which will go below. Similarly, that is, we are considering all the atoms as small spheres. So we have the upper part which will have its reflection on the lower part, and the lower part will have its reflection on the upper side. And here we have these two hydrogen atoms. The reflection of the hydrogen on the top right will come to the bottom right, and the reflection of hydrogen on the top left will come to the bottom left. So here we have these two hydrogen atoms. This one which has come down to the left hand side, and this one which has come down to the right hand side. Then we have two hydrogens. It's on the bottom side. It is a phase. One hydrogen is facing us, the other hydrogen is away from us. The reflection of the first hydrogen which is facing us will come to the upper side. It will still be facing us, and the one which is on the back side, or it is behind the plane, it will go behind the plane but to the upper side. Now we can compare the first orientation and the last orientation. These two are similar. These two are indistinguishable. So now we have a symmetry operation which has produced a new orientation which is indistinguishable from the first one. So what's the symmetry operation we have performed? We have performed a combination of two symmetry operations. First is the rotation, followed by reflection through a plane that is perpendicular to the rotation axis. Okay, so that's a combination, and this symmetry operation is called improper rotation, or the element is called improper rotation axis. It's actually mentioned as improper rotation axis, not the improper reflection plane. It's always mentioned as improper rotation axis. Here it's the same example. You can see first the molecule has been rotated through 90-degree, and then it has been reflected. Okay, and it gives the similar appearance. We can see that the first orientation and the last orientation is same or similar. So we can call this operation as improper rotation axis. So now we have learned all the symmetry elements. The first one is identity element. The second one is first one is identity element. Second one is the line of symmetry. Third one is the plane of symmetry. Fourth one is the point of symmetry or inversion center. Fifth one is improper rotation axis. Okay, now moving on, let's see. Now here is something I want to let you know. Here we have symmetry operations and symmetry elements. Symmetry operation, the first one is identity operation. Okay, it's actually doing nothing. So it's always mentioned as symmetry operation. Now there are cases where we mention it as symmetry element also. Then still it is called identity element. Either identity element or you can call it as identity operation. And see how it is denoted. It is denoted, or it's denoted by the simple capital E. Next is rotation. A rotation by a particular angle. Rotation by a particular angle. And what is the symmetry element? It's an axis. You can see here n-fold. I'll explain that later. So we have rotation is the symmetry operation and axis is the symmetry element. It is denoted as capital C. I'll come to that end later. Next symmetry operation is reflection, and that reflection is the symmetry operation, and mirror plane or the imaginary plane is the symmetry element. It is denoted by sigma. Next is inversion center. Inversion is the operation performed and the point is the symmetry element, and it is denoted by small letter I. Next is improper rotation is the operation, and the symmetry element here is an axis of rotation followed by a mirror plane perpendicular to the axis. You should also mention that it is perpendicular to the rotation axis. And here improper rotation is denoted by capital S. Now let's see the symmetry elements of water molecule. Symmetry elements of water molecule. The first symmetry, what is the first symmetry element we can write down? The first symmetry element is identity element. Any molecule, when we write, we should write identity element as the first symmetry element. So in water molecule also we have the first symmetry element as identity element. That is, you can write this capital E. The next symmetry element is the axis of rotation. And how will you define this axis? It's an imaginary axis passing through oxygen, bisecting the angles formed by the two hydrogens. And rotation through this axis about 180 degree will give us a similar appearance. Here also the hydrogen has been colored so that you can identify what has been done here. It's being rotated in the clockwise direction. What's the next symmetry element water molecule possesses? It's the plane of symmetry. Can you just think of the planes the water molecule can possess? You can pause the video and you can just try out which are the planes water molecule possesses. Okay, the first plane is the plane passing through oxygen. The plane passing through oxygen and bisecting the angle between the two hydrogens. Okay, here it's being reflected and it gives a similar appearance with the we have the hydrogen has changed its position. The reflection of the red edge has gone to the left hand side. The reflection of the blue edge has come to the right hand side. Is there any other plane you can think about which will divide the water molecule into exactly two equal halves? Here, water molecule is V-shaped. You can take two pencils and you can have it as a V shape, and you can try out how you can cut the water molecule into two equal halves. Here is the next way we can cut the water molecule into two equal halves. That is a plane. That's a plane which passes through all the three atoms, both the hydrogens and the oxygen. It cuts all the three atoms into two equal halves. So we have all these as small spheres. We'll have one hemisphere on above the plane and one hemisphere below the plane for the oxygen for the two hydrogens in the same way. And please try out if there is any other symmetry elements you can find in the water molecule. Okay, and as so far we have mentioned three symmetry elements. The first one is identity element. I mean the symmetry elements of water. The first one is the identity element. The second we have rotation plane, and third we have the reflection plane. But there are two reflection planes, one passing only through oxygen and the other passing through all the atoms. Moving on, next we have combination of symmetry elements. How we can combine two symmetry elements. Here we have water molecule. Here I would like to mention one more thing. Here we have the water molecule. Again, the water molecule with the two hydrogen and oxygen in the center and two hydrogen atoms on two sides. And it has a V shape, and we are rotating the molecule. How many degrees are we rotating this water molecule to produce the first similar appearance? Okay. We are rotating it through 180 degree to give the first similar appearance. Here we have the hydrogens which have changed their positions, but the rotation is through 180 degree. Here we have the rotation through 180 degree. There was this. Here I would like to tell you what is this N or N-fold axis. The total rotation we perform on an object is through 360 degree. And how do we find this N? Here, in the case of water molecule, we have rotated the water molecule through 180 degree to get the first similar appearance. So we'll write 360 divided by 180 and you will get it as 2. The factor will be 2. And so we can call that axis as two-fold axis. What do you mean by two-fold axis? When the molecule is rotated through 360 degree, it gives us two similar appearance. So it is called two-fold axis, and the axis can be denoted as C2. Okay. If the molecule is rotated through 90 degree or while rotating through 90 degree, if we get the first similar appearance, then we should write it as 360 divided by 90 and you will get the number as 4, and then the axis will be called four-fold axis, and the axis can be denoted as C4. In the case of ammonia, In the case of ammonia, BF3 and ammonia. Okay, you can do these two, ammonia and BF3. Please find out what what's the value of N and what it is called. What fold axis is there in ammonia and BF3, boron trifluoride or trifluoroboron. Please find that out. Yeah. Coming back to combination of symmetry elements, the first symmetry operation we have performed here is rotation through 180 degree, and we have got a similar appearance. Similar appearance with hydrogens which has exchanged their position because we have rotated the molecule through 180 degree. Next, I am performing another symmetry operation, that is reflection. And please check the reflection plane I have chosen here is the one which passes only through oxygen. What will happen when we reflect through this plane? Again, the red hydrogen will have its reflection on the right hand side, and the reflection of the blue hydrogen will go to the left hand side. So here we have the oxygen in the middle with the blue hydrogen, or the reflection of blue hydrogen has come to the left hand side, and the reflection of red hydrogen has come to the right hand side. Now you can check the first appearance and the last one. First one and the last one. The first one and the last one looks the same. Okay, so we have got the same orientation, or we have come back to the same orientation as the original one. So here now we have to compare what has happened in the first appearance and first orientation and the last orientation. Here we have taken it as the combination of two symmetry operations. First we have performed rotation and then we have performed reflection. But we have to check what has happened to the original, what has happened, or what's the relation between the original orientation and the final orientation. There will be one symmetry operation which has been, or we can write the combination of two, rotation and reflection, as one single symmetry operation. Please find out what you can write in between these two, or what can you say that has been performed in between these two, the first orientation and the last orientation. So you have a few things to work out. You have to find out the rotation axis of BF3 and ammonia, and you have to find out what fold the rotation axis is, and then here you have to find out what is the symmetry operation that has been performed, that a single symmetry operation that has been performed in between these two. Okay, thank you.